Welcome back to your 9-3 intro notes. We just discussed what is a zero. How many zeros can a quadratic have? 2, 1, or none. We talked about how do you find a zero? Well, at this point, we only know how to graph them, and then we identify the intersection points, point or no points. And then we talked about the fact that we have 5 total techniques we can use to get the exact same answer. Some techniques are definitely more useful than others, but they all do eventually get to the correct answer. So we have graphing, square roots, factoring, complete the square, and the quadratic formula. So I'm going to try to help you understand the connection between the graph and using square roots. So the first thing I have is a little piece of patty paper, just like we used in our class. I remember that we practice the parent function. The parent function is where the parabola starts at 0, 0. The next point is at 1 over 1 up, 1 over 1 up. So we're creating our parent function right now. And then we go 2 over 4 up, 2 over 4 up. Some of you might like to think of it as 1, 1, 1, 3, 1, 1, 1, 3. So again, 1, 1, 1, 3, 1, 1, 1, 3. So this is our parent function. This is the basic form of a parabola. And I can move this all over when graphing new parabolas. So this is like the basic form that I can use to create other forms. So if we look at this, that is the parent function. It's saying, hey, take this parent function and go down 4. Take the parent function and go down 4. You got it. So 1, 2, 3, and 4. So now I'm going to lift up my patty paper and mark my points. So I went down 4. I know I go over 1, up 1. Over 1 and up 1 on the other side as well. And then we're going to go here and here. And go ahead and connect them. Beautiful. And now we're supposed to identify our zeros. Remember, it says right here, what is a zero? Well, a zero is where it intersects the x-axis. So I'm going to get a yellow marker and I'm going to mark it. I can see that right there, where I've highlighted in yellow, is where it intersects. Let's identify those points. Well, this point is 2, 0. The x is 2, the y is 0. This one is -2, 0. The x is -2 and the y is 0. Some teachers might want you to identify them that way. I have a little tickle in my throat, sorry about that. Or you could also say that the zeros are 2 and -2. Either way. I think it helps if you do it this way to see what I'm doing on the next part. So now we know what the answer to this is. Now let's look over here. So you're like, why did they make that 0? Well, who was supposed to be there? It's supposed to be a y. And when finding our zeros, we make our y's 0. When finding our zeros, we make our y 0. Why? Because every point on the x-axis has a y-coordinate that's 0. So when we force Mr. Y guy to be 0, we're forcing ourselves to find the value of the x's. So here we go. First thing I recommend kids do is draw a line at the equal sign. The only thing we're allowed to have over here is the variable squared. I'm only allowed to have the variable squared. I see I have a little friend sitting there. That friend's got a vamos. Get out of here. So what is the opposite of subtract 4? Well, the opposite of subtract 4 is to add 4. So I'm going to add 4 to both sides because whatever we do to one side, we do it to the, yep, you just finished it, other. Whatever we do to one side, we do it to the other. We know that 4 take away 4 cancels. I have x squared equals 4. So think about what numbers would work here. Like if I just drew a blank instead of a x, and again, a variable can represent anything, what could go in that blank spot and make sense? Most of you are like, well, I'm going to use a pencil so I can erase it if need be. 2. 2 squared is 4. 2 squared is 4. Is that a true statement? Yes. But there's another number that also creates a true statement. There is another number that would work here. What is it? Let's try negative 2. Negative 2, 2 negative 2's. Negative 2 times negative 2 is also positive 4. Check. We actually have 2 separate answers. That could be it. But instead of filling out a blank and guessing and checking, we're going to actually go back to our original equation, which is x squared equals 4. So I have x squared equal the number on the other side, and I'm going to use square roots on each side. The square root of x squared is x. We learned that in chapter 7, that the square root of a square is what's inside. And if you want a little recall of that, 2 x's. When in doubt, we write it out. We look for sets, we bring it out, right? A set of 2, a square root is looking for sets of 2. When in doubt, we write it out. We look for sets, we bring it out. We found a set, we bring it out. So that's why the square root of x squared is x. But what is the square root of 4? Now most kids, this is the error. Oh, they just say 2. Well, that's true. But we have the principal root and the negative root here. So we have a plus and a minus 2. Because as we saw here, both worked. So we're going to have a positive and negative of 2. So our final answer is 2 and negative 2. So you can see that no matter which technique I used, I got 2 and negative 2, 2 and negative 2. You could also write these as a point if that's your jam. Some teachers in your future will appreciate you writing it as a coordinate point, x and y. So there we go. Congratulations. Bye.